Hey students, this is Miss Went, and what I want to do is give you a little introduction to a PhET that you're going to be using today. So to find it, if there's not a link on Schoology, I'm just going to type in PhET and skate park, okay? And the thing is, there's going to be two versions of this. The second version is brand new, and we want to make sure we have the one that's called Skate Park Basics, okay? Just the regular skate park won't have the word basics on it. And that one's cool, but we are not ready to do that yet. All right, so we are just learning right now, so we want to do skate park basics. So Googling it's cool. Otherwise, I think there's probably a link in Schoology for you. Now, there's different worksheets and activities that go with this, so I'm not going to follow a certain lab worksheet. I'm just going to show you some things and how this works and some things to notice, and then you'll follow the directions on your personal sheet step by step. Okay, so we're going to do most of our work here in introduction. You can see there's also a button for friction, which we know is a force that's going to act against our moving skateboard person here. And then there's also a playground where you can kind of make some wacky courses of yourself. But we're going to start with intro here. Okay. Now I'm going to, we got normal motion here. You can see there's some different types of tracks you can try, but this just general curved one is good to start with. We are able to change the mass of our skater, and you guys know that that's going to change how much force we need and how gravity affects that skater. I'm going to turn a bunch of these guys on here as well to help us kind of keep track of stuff. So we have a speedometer to mark our speed. And then we have a chart here that's got three types of energy. And we don't know what those words mean yet. And that's the purpose of this activity, is to help us figure that out. Okay. We've got a grid that kind of shows our height here. And I'm just going to pick up the skateboarder here. And ooh, notice when I move her, my graph over here is changing, right? So it's kind of changing based on her height. And then over her head, there's a blue circle. That blue circle matches the word potential, and it also matches the potential on this bar chart here. All right. So I'm going to let her go. All right. So she's skateboarding on the ramp. Now there's no friction. So she's an object in motion, so she'll stay moving. But her speed is not the same. So you can kind of see there's a pattern of her speed. As she goes down the ramp, she speeds up. And when she's up at the top of the ramp, she's got a lower speed, faster speed at the bottom, and then she slows back down again. And we can kind of put her in slow motion to see that. Okay, so her speed actually comes to a stop for just a moment at the top. And then it'll speed up as she goes down. And if you've ever, ridden your bike down a hill, you know that as you go down a hill, you speed up. And then when you start going up a hill, it slows down. You have to start pedaling again. But she's got this pie chart over her head. And you notice at the top of the ramp, it's mostly blue, and then it's mostly green. And then up here, it's mostly blue again, with a little piece of red. And if I look at the bar chart over here, the bars kind of match. So like right now, she's mostly blue. That represents this part of the chart with just a little bit of green, a little bit of orange. That matches what's going on over her head. And if we let her go to the bottom of the ramp, you can see that she's changed mostly green, and that matches here, which is kinetic, and a little bit of red, and there's actually no blue that I see there. Okay. The total here, you can see this total bar is just a touch higher than the green. That's going to be all three of these colors added together. Okay, so like if we pause it right about here, this total would be the green plus the blue plus the red on top. If we put all three of these on top of each other, it should equal the total. All right. So your job is to try to figure out, what do these words mean? Kinetic, potential, and thermal. So as this is changing, what's the pattern with how this also changes? Okay, so we can measure her height here. We can change her mass. We have a way to measure speed. So what does that have to do with these guys? That's what your goal is today. Okay. If you want to try another track, you can see I pick her up and I can let her go. And she heads down the track and off the screen. All right. And then we got kind of a thing here. I can put her back on there if I want to. Put her back in normal motion. If I put her here, this is like where she came off the track here, kind of thing. All right. So that's what this is all about. Is your job is to figure out what these words mean today. Now we also have a friction simulation. So same basic thing. You can pop her on here, but you can change and give her lots of friction. And you can see that that slows her way down. Okay. So I put her up here on top. So this is more like real life, right? Eventually, if you try to just go back and forth, you come to a stop. You can kind of see how changing friction and also changing mass and other things are going to affect that. And of course, you can change the different courses as well. I just clicked playground down here. And so for playground, you can make your own track. Okay, so you kind of drag things. And then if I want another piece, I have to connect the dotted ones together. And then I can, do whatever weirdness I want to do here. Cut things off or whatever. Okay, so whatever track you want, and then you can try to put your skateboarder up there and see what happens. Okay, so she didn't get over the first hill, so maybe if I make my first part a little higher, didn't work. Maybe if I make this part a little lower and try again. There we go. And she got stuck there. Okay. But anyway, so you can make all kinds of changes and do crazy things and whatnot and see, what happens. And, you start kind of breaking laws of physics here, but it's still pretty cool. If you turn your iPad from like landscape to normal mode, you can get kind of some different views and you might be able to make it taller or wider too. And then you see there's another button here. You can see the first button, she's on the track. The second button, she might fly off the track. Let me try to grab her again here. If I put her here. This is a new button. I'm not really sure what that button does. I thought she'd maybe fly off, but it's hard to say. Yeah, same thing. You can figure out what that is and help me out with that. But so anyway, so those are fun to play with, but you're actually going to get most of your answers back here on this intro mode. All right, so that's the main idea of what you're doing today. When you finish, if you go back and try to work on your textbook worksheets a little bit, once you know these words, you'll see them all over the place in your textbook, and some of that will make a lot of sense too. Plan is to do math problems on Tuesday. Hopefully my son will be better and I will be back. So, but you guys are doing skateboard park basics. I think you can finish this and get it handed in today. And then continue working on the textbook worksheets you got on Friday after your test. All right. Have a great day, guys. And I hope to see you tomorrow.